Hello, my name is Ahmed Abdelaziz. I will talk about our project background and problem statement and objectives. Why Psyche? Psyche 16 is one of the most metal-rich asteroids discovered. It is believed to contain large amounts of iron, nickel, and other valuable metals. These resources could support future space exploration, construction, and manufacturing. Why our system? Traditional mining methods rely on gravity, ore transport and stabilization are difficult in microgravity or no gravity. A magnetic-based system provides a feasible alternative. Uh, Problem statement and objectives. The problem statement: efficient ore collection in low gravity, stabilized transport mechanism, non-contact material identification. Objectives: detect metal ore, distinguish iron and nickel, prepare output or for processing.
Hello, my name is Ahmed and our proposed system overview is magnetic collection. A magnetic arm collects metallic ore from the asteroid surface and conveys transport. The ore is moved through the system using a conveyor belt. A stabilization magnet, a permanent magnet under the belt, stabilize ore movement, and sensor chamber. Electromagnetic sensing identifies a metal type. Sorting and storage identify materials are separated and stored. And our contribution. The project include multiple subsystem. Our work focus on the sensor chamber subsystem. Our contribution include designing the sensory coil arrangement, simulating the magnetic field in console, designing the signal conditioning circuit, testing the identification concept for iron and nickel. And now Hakim will continue.
Okay, for the sensor chamber design, we use the following as a procedure to detect the type of metals that we have. We have three coils inside the detection chamber: excitation coil, sensory coil A, and sensory coil B. The excitation coil generates an alternating magnetic field. This alternating magnetic field causes eddy currents inside the metal ore, and sensory coil A measures the field changes caused by these eddy currents inside the metal. The ore passes through the center of the chamber where the strongest interaction occurs with the magnetic field. We used COMSOL multiphysics as our main program to simulate our design. The simulation helped us visualize the magnetic flux density and verify the concentration of the field inside the detection region. We also used it to optimize the placement of the coils and see where it lands best. And we used it to study the metallic ore interaction with the field density. This is the principle of operation for this design. We use the excitation coil to generate an AC magnetic field, which is an alternating magnetic field. The metallic ore enters the magnetic field and causes eddy currents inside the ore. These eddy currents create an opposing magnetic field or creates a distortion inside the magnetic field, the main magnetic field that we have. The sensory coils detects the changes in this magnetic field, and by result they have an induced voltage on them. The voltage difference, this indicates the type of material that we have.
I'm Malak and I'm gonna talk about the electronic circuit design. After obtaining the sensor coil voltages, the next stage that we take these voltages and we try to process them. Because the different voltage between sensory coil A and sensory coil B were extremely small, they could not be measured directly. So amplification was necessary. As you can see here in the circuit, the first amplifier is the differential amplifier that subtracts voltage A and B from each other, then going into an amplifier with 10 with a gain of 10, and then another amplifier with a gain of 10, and then our rectifier circuit, which is called also super diode, that converts the AC voltage to a DC voltage. So it can go to the microcontroller and it can be read properly. We simulate on console across multiple frequencies and we take the voltages from these multiple frequencies, and we have built a datasheet that have been uploaded to the microcontroller. So whenever we enter manually any type of voltage of any frequency, the microcontroller reads those voltages and match it to its datasheet, which is multiple DC output voltages for iron and nickel, and match it to this datasheet and gives an output of the metal type.
Hi, my name is Nour Mohamed. We plan to improve the system by adding a microcontroller, automating sorting, improving the signal accuracy, building a full prototype, and testing more materials. In conclusion, we designed and simulated a system for asteroid ore identification, built a signal conditioning circuit, and showed it can detect materials like iron and nickel with potential for future space missions.